Today we are doing average rate of change of quadratic functions. If you're thinking, I think we've done rate of change before, you're right. We did rate of change with linear functions, and those were straight lines. And so the rate of change of a linear function is called the slope, and the slope is always the same. Because this is quadratic, it's what shape? A U. And so it's going to turn around. So right there tells you it cannot be the same everywhere because part of it's negative, part of it's positive. I'm going to have to tell you what x's I want you to focus on when you're calculating your rate of change. So let's look at all these words right here. So these words are important or else I wouldn't have put them up there. The average rate of change of a function is the rate of change between any 2 points of a function. It is the measure of how a quantity changes over some interval. Now, recall that the slope of a linear function is found using the formula m equals y2 minus y1 over x2 minus x1. That is on your formula sheet, so you do not have to memorize it. It's called the slope formula. The rate of change, or the slope, is your change in y. That's what that little delta means. It means change in y. Delta is the triangle part. Change in x. And if you're looking at a graph, it's how much you rise. How much do you go up and down compared to how much do you go left or right? And you're going to use this same formula to find the average rate of change over any given interval, and actually not just any quadratic, any function that I give you. I could give you any crazy function to look at, tell you what interval of x's, and you can calculate rate of change the exact same way. Now, I need you to listen very carefully right here to what I'm about to tell you. When you are describing and comparing the average rate of change, the positive and negative simply tell you the direction of the graph. A positive rate of change does not guarantee that it's more or it's greater or it's better. A positive rate of change simply tells you that you're going up. So if you're going up, the function is increasing. A negative rate of change doesn't mean that it's less, doesn't mean that it's lower. It simply means if it's negative, which way is it going? Down. And so it is decreasing. Now, I will compare positive and negative rates of change to going upstairs, okay? Going up the stairs would be positive, going down the stairs would be negative. You say, Miss Lusher, what do you mean? Well, if your rate of change is a positive 3, that means you're going up 3 stairs at a time. If your rate of change was a negative 4, that means you're going down 4 stairs at a time. And you'd have to figure out which one was going to get there faster, okay? All right, so let's calculate these. These problems are going to be very wordy. So again, you got to get out of your head of, I see lots of words, it means it's hard. No, you see lots of words because I have to tell you what I want you to do. All right, so when you're reading this, you're going to calculate the average rate of change. So I need to find rate of change, and then my brain should immediately go, if I need rate of change, I need to use this formula. If I want to use this formula, I have to know the x and the y of one point and the x and the y of the other, okay? For the function f of x equals x squared plus 6x plus 9 between x equals 1 and x equals 3. So, I need the rate of change, which means I need to use slope formula. This is my function. What are the only 2 x's that you are focused on right now? 1 and 3. Okay. You need to use this formula. You need to know if x is 1, what is y? You need to know if x is 3, what is y? How did I know that x was 1 and x was 3? Because it told you, it said so. Why didn't you use 2 and 5? Because it said 1 and 3. That's exactly right. You're not being a smarty pants. You're telling the truth. That's what I was looking for because it said to. Now, if you know x is 1 and you know that this is your function, there's a couple of different ways you could get the y. What is one way that you could get the y?
Graphic.
You could graph it. So you could put it on a graph and you could look for the y. Okay? I would use Desmos at that point because, let's just be honest, that'd be easier. Okay? What's another way? If I know x and I know an equation, how can I get y? Well, quadratic formula would solve and would find me the solutions, my x-intercepts. I could just plug in the x's, like my friend said. I could plug x in both places and get a y. Then I would plug in 3 both places. There is another and easier way that Miss Slusher would do this. What do you think Miss Slusher would do? I'm going to put it in the table of the calculator. Because I plug this right here in one time, and then I just look for my numbers. So go to your table, and you do x squared plus 6x plus 9. You enter the function. Then I did double check, make sure I entered the right function, because what's going to happen if I type the wrong function? You're not going to get the right answer. You're going to be wrong. Okay? So now I hit enter. It asks me where I want it to start. Well, I'm going to start at my lowest number, which is 1. And I hit enter, 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 enter. This table is telling me that if x is 1, what is y? True. This table also tells me if x is 3, what is y? 36. These are your 2 points. In order to find the rate of change, you're going to use your slope formula. This is your slope formula right here. It is the fraction with subtraction. Your y's are on top. y2 is on top, its x is up under it. That is just the second y that you have. This is the first y and its first x. So if this is my x of the first point, that's x1. This is y of the first point. That's why I call it y1. This is x of the second point and y of the second point. Now, the formula says y2 goes on top first, and its x of 3 goes up under it. The formula says y1 goes on top, and its x of 1 goes up under it. Now, I could make you do this in your head and subtract these, and then subtract these, and then simplify. But what do you think Miss Slusher would tell you to do? Just go straight to the calculator, right? So you put your fraction first. You type what you see. 36 minus 16 over 3 minus 1 is 10. Your rate of change between x equals 1 and x equals 3 is 10.
So do we not have to do the triangle y and triangle x?
You don't have to write that. So that just means change in y, which is where you change you subtract and find the difference. Now, here's what I need you to understand. That is a positive 10. So what does that tell you about the direction you would be traveling? Increasing. So I want you to write yourself a note. 10 is your answer. That's why I put a box around it. 10 means you are increasing by 10. Or you could say 10 over 1. You go up 10 for every 1 you go to the right. Let's do example 2. Use the graph of the function to calculate the average rate of change between x equals negative 3 and x equals 1. There's a lot of x values on that graph. But this problem told me which 2 to look at. What are my 2 x values? Negative 3, negative 1. So here's what you do. You're at 0, 0. X is negative 3, 1, 2, right here. You go up until you find where you're at on the graph. X is negative 3 when y is right there. X is negative 1, then y is right here. You have a couple of different ways you could approach this. You could say that this is the ordered pair negative 3, 1, 2, 3, 4, 5, 6. and that this is the ordered pair -1, -2, and you could plug it in if you like the algebra. Some of you are very good at that and you like it, so that's fine. I am a very visual learner, and it's just faster to me to count which way I'm going. So, I'm going to do rise, which is my change in y, over run, which is my change in x. So I'm going to start at this point. Will I go up or down to go close to this point? I'd go down. 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8. I went down 8, and how do I get to that point right there? I would go over to the right 2. Now I need you to think about your directions and what those directions mean for positives and negatives. If you go down 8, is that a positive or a negative 8?
Yep.
That's a negative 8. If you go to the right 2, is that a positive or a negative? That's a positive. Now, I hope you don't need your calculator to simplify this, but if you do, that's fine. What's -8 divided by 2? -4. So tell me about the rate of change from this point to this point. What are you doing? You're decreasing by 4 to 1. So I want you to write yourself a note. Decreasing by 4. So if I was going to get you to compare these and see which one had the greater rate of change, you don't even look at the negative. This person is going up 10 steps at a time, somehow. This person is going down 4 steps at a time. Who's going to get there quicker?
Number 10.
Number 10, because 10 is a bigger number. Has nothing to do with that's positive, that's negative. You're actually using what's called the absolute value of the number. Just the number, not the sign when you compare. All right, example 3 is a very wordy question. When you are reading these, where students go wrong, my own children included, they only half read the question, and they don't dare go back and read it a second time. You might have to read some of these questions 2 times. You might even have to read it 3 times. That's fine, okay? For the function g of x equals x minus 3 squared minus 2, is the average rate of change greater between x equals -1 and x equals 0, or between x equals 1 and x equals 2? What's this problem trying to get me to do? To compare 2 of them. I got to do 2 of these, and then I've got to say, well, I got to answer the question, which one's greater? So, I've got to do 2 rates of change first. The first interval has x values of -1 and 0. So, if I know x is -1, I need that y. The other x I know is 0, and I'm going to need that y. Now, this is all for the same one function. So I'm going to draw a little squiggle right here to separate. For the other interval, I know x is 1, and the other x I need is 2. G of x equals x minus 3 squared minus 2. That is my function. What would be the easiest way to get the y values for all these x's? What's Miss Lusher's friend on here? The calculator's table. You take the table and you enter this function. Let me move it to the side. I don't know if y'all can see. My screen's a little crazy. All right, I'm entering this function right here. Parentheses, x minus 3, parentheses squared, subtract 2. That's the function. That is the function I'm supposed to be looking at for all 4 points. So I hit enter. I'm going to start at my lowest point, which was -1. Well, I say I will. If I type it, I will. So my calculator is telling me if x is -1, what is y? 14. When x is 0, what is y? 7. When x is 1, what is y? And when x is 2, what is my y? -1. So now that we know that y's to go with the x's we needed, and they told us our x's, the problem has to tell you what x's to use. You need to find the rate of change. To do the rate of change, you're going to use the slope formula. The slope formula is that big fraction with subtraction. You have x1, y1, x2, y2. The formula says y2 is first and on top, and its x goes up under it. Y1 is 14 on top, and its x goes up under it. What's the fastest, easiest way to get that answer? Calculator. Hit your n over d button first, make it a fraction. 7 minus 14 over 0 minus -1. Now, I'm going to hit enter. I want you to double check and make sure I'm right. I got -7. You need to type it in to make sure I'm right and to make sure you know how to type it in. All right, so we needed to do the rate of change. Rate of change is going to use the slope formula, so that's what I went ahead and set up. The big fraction with subtraction. Now, this is x of the first coordinate, y of the first coordinate. This is x of the second, y of the second. So your formula says y2 should go up front on top, it's x up under it. Y1 on top, it's x up under it. And you take your calculator and you type in everything that you wrote, okay? I got -3. What'd y'all get? -3, okay, good. All right, so now, we're about to have to compare these because ultimately what I asked you is the rate of change greater for the interval -1 to 0 or between 1 and 2? So what I need you to do is to describe to me, what does -7 mean? For rate of change. It's what?
Down.
Back 7 from 0. In this case, because the rate of change is going down, it's going to decrease, okay? So I want you to keep in mind it is decreasing by 7. At the same time, what does -3 as a rate of change mean?
Decreasing by 3.
Very good. It is decreasing by 3. Think of it as if 2 people are going down the stairs, okay? This person's going down 7 stairs at a time. This person's going down 3 at a time. Who's going to get there faster? 7. Even though numerically, like on a number line, -7 is not greater than -3. We're not talking about the number line. We're talking about how fast are they changing. So in this case, the interval -1 to 0 has the greater rate of change. So the interval, so you got to write that statement, x equals -1 to x equals 0 has the greater rate of change. Now, we're going to write a reason so that when you look back at this, you know why we chose it. B/C, what's that mean? Because decreasing by 7 is greater than decreasing by 3. Used to, on your end of course test milestone assessment, you had questions like this that were open-ended and you had to type. And so that is the exact reason they would be looking for, because it proves that you answered the question and that you understood what it meant. Now they've taken away those where you type and it's multiple choice. But I could still turn that into a multiple choice 4 answers. I could have 4 answers, one of which said basically this, the other 3 which said something real similar. You're going to have to slow down when you take these tests and read the answer choices and maybe reread the answer choices. Of all the questions that I end up giving you and in all the ways that I write it, when I give a table, students miss those the most. I don't know why. Because a few minutes ago when you had this equation, what'd you do with it? You put it in the table. I just gave you the table, okay? Now I realize this one does have some negatives. And it's okay. It works the same way. Find the average rate of change between x equals negative 0.75 and x equals negative 0.25 for the following function. There's a whole bunch of numbers. What's the only x value that I really care about? What did it tell me? Negative 0.25, I can't read. Negative 0.75. And so if this is x1, this is y1. The other x they told me was negative 0.25. That's this right here. So that makes this x2, y2. I don't care about any of the other points because they didn't ask me about that interval. So I need rate of change. Rate of change, I find that by finding the slope between these 2 points. It's a big fraction with subtraction. y2 is 8.44 and its x is negative 0.25. I write it up under it. y1 is 3.44 and its x is negative 0.75 and I write it up under it. To find the rate of change, I simply take my calculator and I type exactly what I see. 8.44 minus 3.44 over negative 0.25 minus a negative 0.75. So I want you to type that. Because when it comes time for a test, or the end of course test especially, I'm not going to show you how to type it. I can't. Now I'm going to hit enter. And I got 10. I need you to make sure that's what you get. Yeah.
That's it. They're a little bit.
All right, so I get positive 10. That's what y'all said you got. Now, describe to me what that means about the graph between these 2 points if we were looking at a graph. It's going to increase by 10. So if you're looking at the graph, it is increasing by 10. And you know when we talk about slope, we do 10 over 1. So that would mean it was going up 10 and over to the right 1 in between those specific 2 points. All right, so then the last example is example 5. It says, consider the functions. Now, f of x, exactly, there's 2, equals x squared plus 5x plus 4, and g of x equals negative x squared minus 4x plus 3. Which function has a greater rate of change over the interval negative 1 and 0? Explain. So, consider the functions f of x and a g of x. Which of those, f of x or g of x, has the greatest rate of change over the interval negative 1 to 0? I'm supposed to be comparing. Before I can tell you which one's greater, what do I have to know about each one? The actual rate of change and their y's. So, I have 2 different functions this time. Here's how I organized my work. I did f of x, and for f of x, I have an x that's negative 1, I need its y. I have an x that's 0, and I need its y. Now, I'll do f of x's work right there, and then I'm going to write g of x. Now, f of x and g of x are 2 different functions, so I'm going to have to do their work separately. I'm just trying to get organized to help us both know where we got room to write. Now, f of x used the interval negative 1 to 0. What is g going to use? The same interval. You're trying to compare at the same spot, section of the graph. What are they doing? So x is negative 1 and the other x is 0. What will you do for f of x to get those y's? Plug in the function. Okay? So I'm going to cover up g for just a second. Why do you think I'm covering up g? So I don't get mixed up. I don't get distracted. I'm going to plug in f of x into my table. I have x squared plus 5x plus 4. Now, I'm going to start at negative 1 simply because I need that number. And I need you to verify that's what you got. When I have x is -1, I got a y value of 0. Is that what y'all got? Yeah? When x is 0, y is 4. So right now, I'm still ignoring g down here. I'm only focused on f of x. I need the rate of change between these 2 points. If I need the rate of change, what formula do I use? What's it called? The quadratic solves it. This one is the slope formula, okay? Rate of change is the slope between those 2 points. So your slope formula, let me write it on this little post-it note real quick. All right, so your slope formula is m equals big fraction y2 minus y1 over x2 minus x1. All right. So this is an x and a y. This is x of the first, y of the first. X and a y. X of the first, y of the first. No, except Miss Lusher should have put 2's. I'm sorry. Now, my formula says y2, which is 4, and it's x up under it. y1, which is 0, and it's x up under it. Once you plug it in, how do you find the actual rate of change? You could either do that in your head, or you could do like Miss Lusher and just type it in. 4 minus 0 over 0 minus -1. I get 4. So the rate of change of f of x is positive 4. So what does that tell me about the direction that that's going? What's positive 4 mean?
Going up.
It's going up. So it is simply increasing by 4. That's all it means.
Wait, so on the first one, how did you get, how's it 7 through negative?
Where, baby?
On the example 3?
Example 3. Oh, so on that one, it would have been 7 minus 14 is -7. Minus the negative would be positive 1. So it was -7 divided by 1 to be -7.
Well, I thought you wanted the greater one. Wouldn't negative 3 be greater?
Oh,
than
I see.
7?
So on a number line, yes, I see what you're saying. I'm sorry. On a number line, -3 would be greater. But you're talking about how fast they're changing. If you're decreasing by 7, that's happening faster than decreasing by 3.
It's just whatever number's bigger than
It's just
negative
it's the absolute value. It's whatever number's bigger. Whichever number's happening faster. Doesn't matter the direction. That's an excellent question. All right, so now I got to do g of x. So I'm going to cover up f of x this time so I don't get confused. I'm going to type in the table -x squared minus 4x plus 3. All right, I'm going to double check, make sure I typed the right thing. I did. I'm going to start at -1. When x is -1, y is 6 for function g. When x is 0, y is 3. So that means this is x1, y1, x2, y2. So let's plug it in. Let me grab my slope formula again. Here's my slope formula. y2 goes on top and its x is up under it. y1 is on top and its x is up under it. So to find out what that actual rate of change is, I'm going to type it in. Big fraction. 3 minus 6, 0 minus -1. And I get -3. A rate of change of -3. What does that mean about the direction it's going? It's decreasing by 3. Now, you were asked, which of these functions has a greater rate of change? You don't worry about the negative. The negative simply tells you direction. You worry about which one's happening faster. f of x is increasing at a rate of 4 to 1. So it's increasing by 4 every time. G of x is decreasing by 3 every time. What is faster, increasing by 4 or decreasing by 3? Increasing by 4. So which one has a greater rate of change? 4, which is f of x. So you would say f of x has a greater rate of change. Now remember, I'm making you write this so when you look back at it, you know why. Because increasing by 4 is greater than decreasing by 3. So when you're comparing, ultimately, you ignore the positives and negatives and you just look at the number part. Whichever number part, the absolute value, that's what you're looking at, is bigger, that particular part of the function or that function is your greater rate of change.